Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey folks, welcome to Making Data Simple. Al Martin here, your host. As always, I want to jump in. I've got a great guest today. I've got Manav Gupta. Manav, I don't know if you know this, but I have probably got more comments the last time you were here on the podcast than any other IBM guest. And they were all good. They were like, we need more Manav. So I got you back. We can have the discussions that we have at the water cooler, which are very insightful. I mean, Manav and I debate, we go back and forth, we talk about the state of the industry. The cool thing about Manav is I would say he's one of the most technical execs I know of at IBM. He makes his technical acumen a practice, and he continues to investigate research. So we always have very insightful conversations. If Manav gets agitated, it's because I was late to get on the podcast, but it'll just light him up even more. So we'll get some good insight from him. Manav, welcome to the podcast. I appreciate you being here.
Thank you, Al. Thanks for having me. And yeah, just be forewarned, right? If I start speaking too fast, that's because I'm trying to cram in a lot of commentary, but I hope what's going to be good commentary in a short period of time. So we'll see.
It'll be good commentary. I got a lot of questions for you, many of which you have discussed. Feel free. I mean, this is like we're at a bar having a couple of beers, and we're trying to outline the state of the industry, I would probably say. But before we jump in, I know you were on before, and I would encourage everybody listening to go back to that previous episode. I'll make mention of it, or I'll put it in the show notes. But please give us a little background on yourself, if you would.
Listen, I think the best way I can describe myself is that I'm a technology hobbyist. That's the best I can describe. I love tech. I geek out at all kinds of tech that there is, whether it's from, back in the day, distributed systems certainly is what I cut my teeth on, C++, prior to that, Fortran, assembly, building APIs, maintaining APIs, both within startups at IBM. And then I think I found my sweet spot in being at the intersection of product, clients, and what they're trying to do, and research. So that's what I do. And in that capacity, for the last few years, I will work as the CTO for IBM in Canada, whatever that means. But I'm having fun. Just to give you an idea, so I spent bulk of last year co-developing what is now known as the IBM Context Forge, which is this agentic, I call it agentic infrastructure, which supports both MCP and A2A. It's got over 3,000 stars on GitHub. And if you're still struggling to adopt agents in the enterprise and you're trying to figure out how to use MCP servers at scale, you need that thing. So we'll talk about that and a few other things as we go along.
Fantastic. Let me ask you this out of the gate. How do you maintain your technical edge? You're a VP at IBM. You run a team. Well, how do you maintain your technical ability? What's the secret?
I don't know if there's a secret, but I think it's par for the course. I think it's almost expected, right? Now, right? So I think I'm maniacally focused on what I'm spending my time on.
But you're still coding, right? I mean, this isn't just maintaining a level of technical architecture. You're in the code.
Oh, absolutely, yeah. And code, yes, I've done the full circle like many people have, gone from handcrafting code to using AI tools to back to handcrafting code. So I've gone that full circle as well. But I think the only way you can do that is if you maintain a level of technical curiosity, honestly, right? And I hate nothing more than being in a conversation with a client or with my kids and then trying to explain
or with your kids.
Or with my kids as well. I know. I have three little boys, 9, 12, and 15. And even with their projects, like I'm trying to teach my older two Python, I can't teach them if I'm not hands-on. At the same time, I'll get into, maybe some of this is just my imbalance of my personality. I'll sometimes get into debates with researchers within IBM. And that resulted in me fine-tuning a version of Granite that I think just about inched ahead the IBM research published model on GSM 8K benchmark. So, I mean, it's fun, keeps me busy.
So your kids are coding and enjoying life? You think they're going to stick with tech?
I think right now they're in a mode where for youngsters, YouTube views as currency. So when they see their dad being interviewed on a podcast such as this or some YouTube video, that to them is cool. How long that stays like that, we'll see.
And you have your own podcast, speaking of, right, too? You just started one. You give it a plug here if you'd like.
Yes, I just started one, so I'm following in your footsteps. I've not publicized it quite a lot yet, but I've spent more time than I care to admit. It's called Ship AI, not to be confused with AI. So it's Ship.
We'll have to beep. Ship AI. Why'd you decide to call it Ship AI?
What I'm finding is like unlike any other tech, shipping a product or an AI capability into production at any enterprise other than a greenfield space is just a whole new level of complexity altogether. So I found that I spend majority of my time last 15 months working with many of the largest organizations trying to do just that. So I thought, this is an area where the circles that I hang out in, and maybe I would like to pretend that I know a little bit about. So that was the reason behind, shipping AI or AI-enabled services into production.
So just look up Ship AI, and
Yeah,
it'll take you to Manav
absolutely.
Gupta.
Yeah,
Fantastic.
that's right. Yeah.
All right. Well, that leads me to a few questions to start right off
Yes,
the
sir.
top. I mean, I want to talk to, speaking of getting AI into production, I mean, I was just looking at another Gartner. I mean, this seems like it had changed a while, but some Gartner feedback that 80% of these AI projects are still not in production. They're not seeing ROI, the C-suite. But I don't want to get ahead of myself. Let me jump back for a second and just say, look, I want to talk about the state of tech, which is essentially going to be the state of AI right now. If you were to summarize, I mean, you do a lot of research. Again, we were talking in the cafeteria the other day. How would you summarize the state of AI in your mind right now? Go wherever you want to go on this. What's your take?
So I think, oh my God, this question alone can set me off for the next few minutes. But
That's what it's
I'll
intended to
try.
do.
Yeah, I'll try to summarize. So let's just start at the very top. ChatGPT hit 365 billion annual searches in 2 years. It took Google 11 years to get there. So just to keep in mind, to me, that's not an evolution. That's a different species altogether. It's a different species of technological adoption. And then you would think that, hey, this is a flash in the pan. It clearly is not. So I'm sure you guys have all seen and read charts about how long it took to 1 million users. Ford Model T, as an example, was what, two and a half thousand days to 1 million users. iPhone, if you remember, the original iPhone, 74 days. We thought that was amazing. ChatGPT with literally no marketing, 5 days. You think, okay, that alone might be again flash in the pan, or maybe an outlier. But then if you look at time to 100 million users, it took the telephone, I mean, arguably the tech that brought humanity close, 75 years to get to 100 million users. ChatGPT, 2 months. And then when you drill down further into evolution of AI, I think there's a whole new level of Cambrian explosion that has happened. If you go to a website such as Our World in Data, you'll be able to see models that are large-scale models that have been developed by various countries since 2017, since that eponymous "Attention is all you need" paper. But here's the crux of it. If you look at any of these graphs, whether it's from Epoch AI, World and Data, etc., if you look at what we call truly large-scale, planetary scale systems that are being trained now in the world, currently the US leads the race. So there is something like 155 odd models that are trained in the US and available, exceeding 10 to the power of 23 flops or floating point operations. Now, I know 10 to the power of 23, that is such a huge number. I picked this up based upon how these models were performing on MMLU, or a massive multitask language understanding benchmark. And this is where these models begin to be closer to human performance. I mean, widely acceptable metric on or performance on MMLU is 86.3, considered to be a knowledge worker. So if you put that in mind, 10 to the power of 23 floating point operations, that equates to somewhere between 1 to 5 gigawatts of power. I mean, that's equivalent to some 1,100 homes in North America being powered for a year. You're talking about training costs somewhere between 5 to 100 million users. I mean, that's just thanks to that huge variance is thanks to what DeepSeek has done in China. And at that point, you're talking about upwards of 10, 20,000 GPUs for an extended period of time. And certainly with the newer models that are being made available, Opus 4.5, GPT 5.2, etc., they're even bigger. So globally, at a macro level, the AI world is no longer about just AI or who has the best AI. It's really who has deep nation-state capital that can withstand all the geopolitical turbulence that's going on and invest in building these planetary scale models and continue to invest and improve. Once you put that lens in mind, all of a sudden, the AI race in consumer AI, let's start there, it becomes more about capital and infrastructure, which is why you see significant concentration of wealth that's going to emerge. You're going to see, I'll say, preeminent winners already being declared. So there was a point in time where we thought there's only going to be one model to rule them all. I think suffice to say, we are beginning to see almost this bifurcation that's happening. You're going to see more and more frontier models that are going to be trained on more and more data. And then you're going to still see open source try and catch up. And open source, mind you, has closed the boundaries, but it becomes a capital game. How much capital can be thrown at this? We are at what, third, fourth crank at the wheel? Imagine another two cranks at the wheel at the turn of this. At that point, you're talking about close to $1 billion being invested into building a model. That kind of sustained capital is only going to be available in the hands of the few, not the many. And then you add into it other modalities, right? So predominantly what the world has been enamored with so far, up until a few months ago, since Nano Banana, was predominantly text-based models with various modalities, code and language and so on and so forth. But now, with the vision models, and what Jan LeCun and Meta and others are starting to build, what Tesla is building with what they're calling world models or vision language as action models, VLA models, that all of a sudden becomes that the race is no longer just about the digital world. It now starts from the digital world and goes to the physical world. Let me pause there before I go into kind of the steps to upgrade.
There's so many minutes. So where you're about to go, I presume, is physical AI. So yes. I think there's this rhetoric or the narrative in the market has been, hey, white collar jobs are at risk, but blue collar jobs, you're good. But with physical AI, everything's at risk. It may come from the white collar jobs first or more, or in a quicker state, but the AI robotics is coming in the physical AI is coming for the blue collar jobs just as well, is it not?
I think they're going to all start from different inflection points. So I kind of see where my head's at right now and what I see. I think there is 2 points of view. I'm going to call it largely the American point of view, and then what China's doing. So I think if I look at the likes of Tesla with XAI and to some extent even Meta, they want to build neuromorphic, brain-resembling, AGI type of humanoid robots that will do wide array of tasks similar to humans. Whereas what Chinese companies seem to be doing is they're relying on their massive expertise and infrastructure in building, let's call it good enough machines or purpose-built robots for different scenarios, and injecting these VLA models into it for whether it's for warehousing, whether it's for packaging, whether it's in health sciences, in transportation, and so on and so forth. And I think where the real battle is going to be fought in terms of physical AI, the emerging markets, emerging economies is where these two giant powers are going to collide. So that's Latin America, that's going to be parts of Europe, that's going to be India, certainly Africa. That's where we'll see the real test of this thing. But the reality is, since you talked about physical AI, the number of true models that have been, not models, are robots, industrial robots that have been deployed in China, they far outpass the rest of the world combined. It's not even a debate right now, right? In fact, with the Unitree G1 in China, you can buy that robot, that humanoid, for $16,000, compared to the cheapest entrant in the Western market is at $120,000. You're talking about two completely different ends of the spectrum. And I know I'm veering off from your question.
No, that's good. Keep going.
So if you put that in perspective, and then you talk about, okay, what type of jobs are going to be impacted? I think the easiest for AI to do is what AI is already trying to do with agents, and the largest and the best model that they can build, which is go after the knowledge worker economy. I think in that scenario, anybody that's in information technology, anybody that's in financial services industry, in analysts, anywhere there is a corpus defined, all those jobs are going to be impacted in some shape or form. Whether they get eventually eliminated or augmented, I think the debate is still raging. There are, again, there is one view which is the historic view that if you look at information diffusion, whenever we have these type of seismic shifts that have happened, they've always created new jobs because the old jobs have disappeared. Maybe, but I think the first time we are going to have a technology where it can self-learn. So then we start going into, well, it's not just AI, it's not just physical embodiment of AI, it's also about AGI. And I think that's the thing that really freaks everybody out. And I think the fascinating thing I find about AGI is it's not that there is any disagreement anymore between any scientists. You pick from Kurzweil through to Jeffrey Hinton to Yoshua Bengio, you name it. There is no longer debate around will AGI happen? I think the debate now is on the timeline, anywhere between 2029, which is 3.5 years away, which was the original timeline predicted by Ray Kurzweil, all the way now through to, there are some outliers that talk about 2050, but certainly within our lifespan. So I think the real influence is going to be the combination of the physical embodiment of however narrow we define AGI to be. That absolutely is going to have a tremendous impact on jobs that were historically done by either, I don't want to call it the disadvantaged humans, but to some extent disadvantaged humans and displaced humans. So look at what JD.com is doing in China. They have now dark warehouses. So if you don't know what a dark warehouse is, it is as the name suggests. Robots don't need light. 99.9949 availability, no humans involved. The entire warehouse for shipping is run by robots. Fulfillment through to picking off the carts off of the trucks onto the loading bays, onto where they get stacked, onto fulfilling the orders, completely dark. I mean, that's job displacement, right? So you'll begin to see you have parking valet robots that are now being introduced. Look at what Waymo has done with taxis, right? Which is I'll call it the American embodiment or the North American embodiment. What they logged last year, what was it? 400,000 hours or something of that effect, like well over 100 million miles or so on that they logged. So we'll begin to see a lot more of those inflection points emerge, which effectively is big tech and AI firms. They will begin to go global. Look at what Meta has done with wearables and cameras. And then, there is this whole interesting debate raging that Meta with the wearable glasses that they have is akin to what Tesla has with the cameras in the cars. They're collecting data. You need that data because when you're training this physical AI, there is not enough data in the world to train the physical AI. So the only way that the physical AI or these world models are being trained is through simulated data, or you increase your surface through which you collect this data. So starting from this year onwards through to next year, we'll begin to see devices that move, right? Tabletop robots, pivoting screens. There is all sorts of rumors around, other home companions that are emerging. And we are already beginning to see the rise of industrial dexterous robots. These are robots with hands. And I think we'll see an inflection point of those in as many as like the next, within the next 2 to 3 years. And I think by end of this decade, Sam Altman's already on record, by the way, that, okay, you'll be walking down the street and you'll see, 7 humanoids walk past you and it'll be normal. End of this decade, early decade, we're talking about the rise of humanoids. So this is coming. This absolutely is coming. So I'm still being very generic. So, if you want me to go deeper into any of those, we absolutely can.
Look, we can go. Yes, I want to go deeper. Let me pause for a second, though. I think it does strike me that in all of this, I tend to be an optimist, and every revolution, whether it's an industrial revolution or otherwise, has always tended to. We've always said, "Hey, this is the apocalypse. This is the end," and then we've come out and it's created more jobs and we've got more work than we've ever had before. However, this is a little bit different. I don't disagree. Of course, they probably said that as well, right? But this is different in that this is the actual. We've got somebody on this planet that's smarter than we are for the first time, and the jobs that are at stake. They can pretty much do anything from white collar to blue collar, as I mentioned. Still optimistic, but the thing that strikes me is that most of the warnings that are coming out from very smart people in the business, as you mentioned, like a Jeffrey Hinton, like a Steve Bartlett, like the CEO of Anthropic is talking. And they're the ones that are saying, hey, we've got an issue here. And the bigger concern, and you mentioned China, there's so many different elements of this. This is a day-long conversation. This is like a six-pack of beer, I think. But it's like, my issue or my concern would be really about some of the governance. Now, I'm not a big believer in big bureaucracy, but you got to have governance, particularly in what we're talking about here. I don't know if we can get out of our own way in terms of the innovation that's at the speed that we're going here. Meaning, the U.S. isn't going to let China get ahead, so we're going to try to do whatever we can. This could create a domino effect. So then if you're a nation state that gets behind, you're going to throw governance to the wind because I got to catch up now. So then the possibility of something somewhere getting out of control and unguarded is real. So I guess in all of what I just stated, what's your concern here? What do you think?
I think let's take a step back. Let's start with where you started, which is why has AI become so good so fast? I think we all need to understand that. And there are at least three things happened. I mean, four things truly happened, which have led us to this path. We all know the rise of smartphones and ubiquitous computing with public clouds, ubiquitous networks. We all carry a mini supercomputer in our pockets, and we don't even realize that that has more computing power than what was used to put a man on the moon, right? So that's one element. The other thing is look at the various form factors that are available beyond just CPU. You have GPUs, you have infrastructure and flops, TPUs, and all sorts of other compute form factors. The second element is data, right? We originally in the 70s, the models that were being developed were minuscule compared to today's scale, right? Like 1 million data sets. Then I think one of the ones that was built was about 10 million data sets. Like the perceptron model in 1960, they were like tiny, right? Then we built the neural LLM, which was I think about 1 million tokens or million parameters. That was early 2000 2001. But now we are talking about planetary scale data systems, right? There is this argument that around the world, with the exception of the growing economies, almost all amount of data that's generated is being captured, at least in the public domain. And the sheer vastness of that data, diversity of that data. So we have these data hungry systems, we have ubiquitous compute. And then the third thing that's happened is the improvements in algorithms. That's to do with architectures, that's to do with optimization of these models, that's to do with efficiency. I mean, look at how some of the walls that were hit around, hey, we are just going to be scaling our transformer architectures, and then you start hitting the data wall or the compute wall. Then we started adding more compute time, which gave a result to the reasoning models. So those 3-4 things combined were the ones that have given these AI models rise to this tremendous capability. And then, so that's the sort of the technical depth of it. And then if you look at since 2012, on any benchmark, whether it is image classification, whether it is medium level reading comprehension, whether it is PhD level science questions like on the GPQA Diamond benchmark, visual reasoning, English language understanding, which famously that superglue benchmark, multimodal understanding I talked about in NLU, the AI models since 2012 have continued in the direction of the human baseline, and AI has now surpassed a baseline of humans on every benchmark, on every task that there is. There is this, like Epoch AI is one of the best places to go if you want to look at the improvement in the efficacy of AI. There is something like 27,000 times improvement done in AI models since 2014. Not 2,700, not 2.7, 27,000 times. And turns out that half of it, or 2/3 of it, was compute scaling. Then we started hitting into the compute walls. And then with the post-transformer architectures and some of the chinchilla scaling laws that the world ran into, another 1,000x improvement happened with algorithmic progress. So just to level set with everybody, that's what's happened in the AI efficacy side. Now think about that form of, if not intelligence, that form of representation of all of humanity's knowledge, made available at fingertips and monetized in a near frictionless mechanism. All you need is access to a website, right, over a HTTP protocol that the world spent 30 plus years establishing. And all of a sudden, you have this Cambrian explosion, right? Historically, what would happen is a new technology gets introduced, but there would be a struggle or a moat of some kind that they had to overcome, that, it's available, but it's available only in this part of the world. So the rest of the world is still, behind. But now this is simultaneous global adoption. The days of a local arbitrage, I mean, look at what Amazon had to do when they went to other markets like India. They had to build Amazon of India. Google had to build Google of Russia, etc. Right? China ended up having their own moat, right? Because of language challenges. I mean, some of that was censorship challenges and so on. So they ended up building local capabilities. But with this new moat of agility, everybody gets the same AI on day one. So all of a sudden, everybody on the planet has access to this pseudo-cognitive system, which is, right or wrong, allowing you to distill and synthesize information, generate code, generate image at a pace never seen before. We can get into all sorts of debates around how accurate it is, I think, or how relevant it is, or slop versus supremacy. I think some of this, what we're seeing in terms of slop versus supremacy, boils down to grounding the AI into truths, or providing it the right context. I think those things will emerge, right? I think we almost tend to lose sight of the fact that, yes, okay, like the best models only work with the right context and the right data. They only work predominantly in greenfield situations. And then when an enterprise has to adopt it, they still have to ground these things. They still have to do, initially it was prompt engineering. Now they're doing context engineering. Now we have come up with yet another layer on top, which is this agentic AI. So that's going to go implement this thing on my behalf and provided some controls and guardrails and so on and so forth. I think those are smaller degree problems to resolve, and they are resolving. But look at the bigger, broader picture. With this Cambrian explosion of, what is it now, 2.4 million models on Hugging Face, over 500,000 data sets that are now available on Hugging Face. I think November and December of 2025, Hugging Face recorded over 100,000 new models being posted there. This is a completely different scale altogether. So
who can afford to make all those models?
I mean, you can call it democratization of intelligence. And I'm using the term intelligence loosely because I know there are still purists who tend to get offended that this is not intelligence. This is information representation in a high dimensional space. Fine, doesn't matter. But researchers are doing it, right? What humanity as a whole is doing, I think the cat's out of the bag, number one, right? Nobody's going to be able to put this thing back into the bottle. Now everybody together is pushing the boundaries of what this tech can do. And I think the changes are happening so fast, so quickly, that anybody, myself included, if they pretend that they are experts, they are not. This is a seismic change unlike any other that is happening with unseen, unforetold amounts of money and capital and nation-state capital being invested for all good reasons without necessarily realizing, or if realizing, but perhaps deliberately downplaying the socio-economic impact of this. I think it's a great game, because the game now is that if you're no longer digital sovereign, AI sovereign as a nation state, you're not going to be relevant. The hegemonic digital powers that have existed for what, couple of decades, they're going to be dictating your nation state policy now.
It's probable what will happen is the nation states that do get behind are going to want to catch up for all the reasons you mentioned, and they're going to throw caution to the wind. So all those gates, all that governance, they don't have time for that. They got to try to catch up. And so something
100%.
like, speaking of the genie getting out of the bag, that would be the biggest concern I would have right now.
No, absolutely. And I know what you're referring to, genie out of the bag, is more on the AGI becoming this thing that becomes uncontrollable. I mean, let's park that for the time being. But let's just talk about purely from a nation state perspective. And I think folks in the West, myself included, I think we tend to sometimes view the progress in other parts of the world from a very Eurocentric view of the world. So, the advancements that are being done in AI in China, as an example, are viewed as a threat, which conversely, advancements in AI in America must be viewed with the same lens by observers in China, right? Mm-hmm. If we were to imagine a polarized world. But look at what China and the Chinese companies accomplished with DeepSeek, right? Constraint of GPU actually triggered innovation on algorithms, resulting into a largest ever single day market loss cap in US history, right? NVIDIA lost 600 billion. The contagion was equally spread across the market. ASML, Broadcom, AMD, everybody was down. And what really shocked the world was how DeepSeek R1, it matched OpenAI's O1 model on a number of benchmarks, right? Like on AMI, on math and code forces, and reportedly for a much smaller, I think 120th or 127th training cost. And by the way, just because we're talking about China, they didn't stop just there. Like that just sparked a Cambrian explosion of models from China worldwide. So if you now look at any of the open benchmarks, the Chinese models, in fact, what China has done is they've actually adopted Meta's playbook, where what they are doing is they are making the models available not just open source, but also open weights. And there was a point in time up until 23 and 24 where open source used to be 10 to 20% behind the frontier model benchmarks. But now the gap between open source models and the frontier models is less than 5%, like 1.1 between 1 and 3%. So what they're doing is they are flooding the market with good enough models that are free under a highly permissive. I think many of these models are available under Apache 2 license with open weights, so that it's now flooding the market with. It creates credibility of Chinese companies. It is expanding the market, which I know many business leaders love, but it is undercutting the business models of the American giants, right? So we're certainly beginning to see that as well. The other thing, of course, yes, go ahead.
Stop you there if I could just ask a question on that.
Yeah.
Look, I enjoy listening to you, so I hate to break in, but like we're having the economic forum in Davos right now, and as I'm listening to it, it's like, well, U.S. is so far ahead. I know your feelings on what you've seen with China, the models, etc. Do we really lead the race right now?
I think if I was to summarize it, I'm going to say, I think, however incorrect my analogy is, the way I like to think about this is it's the body versus the brain type of discussion. I think a lot of the US models, they are still the frontier models. They are still top of the benchmark, but they're also spending exponential money in building and training those models. Whereas what is happening in China is they have, I'll call it the brain approach, I'll call it the body approach, which is good enough models, and they are leveraging on their areas of strength, which is their manufacturing might. And then the other thing that they've done is, or three other things that the Chinese government has done. One, they created this new investment policy that they're calling that, I think they call it EDWC, East Data, West Compute, because of how the geographically how the country is located, where East has concentration of humans, but it has the energy is too expensive. On the west coast is they have cheaper energy. The weather is more conducive, so they're actually using that to create a nationwide AI compute infrastructure. So the idea is that they'll train the models in the west and have inferencing in the east. I mean, think about how clever that is. Second thing that they've done is they've created this thing called Big Fund 3. So as the name suggests, there were two versions of this Big Fund. Big Fund 1 was like 19 billion. Big Fund 2 was about 20 odd billion. And Big Fund 3, it actually is bigger than US CHIPS Act. So the US CHIPS Act was about 40 odd billion dollars to maintain the North American and the US supremacy in chips. China's investing 47 odd billion dollars. Now they're behind the curve, mind you. Like their fabs are only at something like 27 nanometer. They did prove that they could build a 7 nanometer chip, not quite the NVIDIA H100, 100s yet, but good enough. So what they're trying to do with $47 billion at their disposal, and by the way, our dollar goes a long way there, is they want to compress 30 plus years of innovation in sub 15. And they'll get it there, right? That's plenty of money. And then the third thing that they've done is this thing called C2Net, or China Compute Network. We're now trying to combine it all together and build an ecosystem that enables companies to consume and invest into all of this space. So broadly on AI, that's what China is doing. Now take all of this and apply that to the manufacturing might that is in China. There is reportedly something like 200 startups in China working in various forms of robots, like true robots, like how the International Federation of Robots defines a robot, right? They are the only country that I know of in the world that is now doing robot games, right? They've done it in 24, they've done it in 25. Most industry, I mean, if you Google videos, you'll find videos of robots sparring, boxing, playing soccer, running, sprinting competitions, and so on. Are they as cutting edge as what Tesla is doing with Optimus? Maybe not. Are they good enough where those robots can be applied in, as I said, warehousing, in packaging, industrial power plants, like industrial plants, and so on and so forth? Yes. So everybody's playing to their strengths. So the broader overarching narrative here was around nation states. So I think that's just China and the US. But then look at what the rest of the world is doing, right? Like the rest of the world also wants to catch up as well. So there is some reportedly, I think about just shy of $1 trillion that's been committed. Bulk of that from UAE, Saudi Arabia, India, and France, UK. Everybody wants to make sure that they are digital sovereign as well. So every nation state that has humans in there and significant number of humans in their boundaries, they're going to form their own alliances to protect their own interests. I think that is absolutely going to happen. So is China behind? Maybe they are behind, but not as far as we think it is. I think on the frontiers of AI, if we measure purely in terms of frontier model performance, no, they're absolutely behind. US is ahead. But I think that's just one metric of looking at how AI is good.
Did the limitation of GPUs actually backfire? What's the saying? It's necessity breeds innovation.
So there is a little bit of that, but I also think that what ended up happening is how the export controls were imposed by the US. They were, I'll say, they were those export controls. They were implemented in phases. So I believe the first one was in 2018. Then I think in October of 2022, the Biden administration, they added additional controls, and the intent was explicit to cap China's ability to train frontier models. Now, what was interesting is that even though when the US implemented these export controls, Chinese companies, they had already started acquiring not as powerful, but the available at the time NVIDIA A100s. And then the first sanctions that were implemented, they were implemented, the ones in 2022, they were only implemented on the NVIDIA H100s. Basically, these are the ones with high memory bandwidth or high bandwidth memory HBMs. So what the Chinese companies were able to do is they were able to acquire the A800s, the H800s, which are the lower capacity, lower in terms of memory, but in terms of raw compute, they still have high raw compute. Now, the US administration eventually closed those loopholes a year later, but it allowed the Chinese companies to acquire those GPUs and thousands of those. Now, to your point, necessity breeds is the mother of invention. What these guys did do with DeepSeek is, I think, three critical things, right? One is the new attention mechanism. So with DeepSeek V1, they had proved what is known as multi-headed latent attention, or MLA. So basically, all transformer architectures, all models that we know of today, they're all based on transformer architecture, that the original paper that came out of Google. And then the way it works is to compute associations between words and the relevance of one word or one token to another, they have to build this giant key value cache. So what the multi-headed latent attention did was, it is an innovation. It reduces the amount of memory that's required by as much as 94%, 93.3 to be exact. And if you want an analogy, like I was trying to explain this to my kids. So the way the key value cache works is, imagine you're trying to find in a skyscraper, you're trying to find a room. In order to do it, you light up all rooms in that skyscraper. That's the key value cache. Whereas multi-headed latent attention, you only need to turn the lights on in that one room that you need. That's one innovation. The other thing that they did was the mixture of experts model. So instead of so the way it works is, the way when you have these models, you have certain layers in your model that act as experts on certain dimensions and certain topics. So what these guys did was, they came up with this novel concept that rather than each query being routed to all layers in this massive network, they have a smaller subset of layers that are a expert in different topics. So those two certainly helped, right? And then the last fundamental thing that these guys did was, with DeepSeek V3, they came up with this new hyper simplified way of providing reasoning. So what used to happen was, and this is known information, that when the scientists, when they would build these models, we use reinforcement learning. I mean, we all know what reinforcement learning is. We teach our kids that way. But then you give what's known as a reward mechanism, that, hey, if my kid does well, I'm going to give the kid a reward. The Chinese scientists, they came up with a DeepSeek as an example. They came up with a dead simple algorithm, which is now known as the Group Relative Policy Optimization, or GRPO. And they basically said, you know what, rather than having a fancy convoluted way of providing a reward model, we're going to keep that thing dead simple. But we're going to let it run for a longer period of time. And what they observed over time was that the model started developing self-correction or self-reflection. That, okay, it went down a path of trying to solve a problem, And as it's validating its steps, it realized that it made a mistake and it doubles back. What's also known as the aha moment. So to your point, does necessity breed invention? It absolutely does.
But now it's the opposite effect, because to my knowledge, now the US government has approved the sale of high performance GPUs to China. Specifically, I think it's the H200s.
That's right.
And now you got people like the CEO of Anthropic, Dario, as we mentioned earlier, is saying, why would you do that? That's like giving nuclear capability or selling nuclear bombs to North Korea. I think that was his analogy.
I think that's exactly yes. I think my view on that is that whatever divide existed, it was so small that I don't think it's no longer a barrier, right? It's just not the right barrier. So the barrier has to be something else, right? If there has to be a barrier, like if we think of that same polarized approach, and if you want to apply a barrier in terms of capabilities that any other nation state, any other actor, or a perceived, I don't want to call it an enemy, but a perceived opponent should have or could have, I think the barrier has to be something else entirely. I think the barrier has to be, like, historically in the West, in the US, it's been all about innovation. So the models that we are building, or that the Magnificent Seven, the tech giants that are building, the vision, language, action models, right? What Meta did with the JEPA series, I think that's what it's called, right? Like what they're building with that. I think that's the area. So we have to be faster at our own game in order to beat others at our game. That's how I look at it right now.
All right, pivoting just a bit, but you mentioned frontier models. We were talking LLMs. We've had like ChatGPT, others, Gemini, could go down the list, Claude, whatever. And then I felt like we were moving toward the smaller, more purposeful models. Do you think that's going to pivot right back to the large frontier purpose models? Because now you can do the same with the large model. So then again, large models will ultimately prevail. They'll just be purposed.
I think what's going to happen is, I think there's two ways this game is going to get played out. So what's interesting is that the token prices continue to fall. There is something like a 1000x decline in the price of tokens. I think when GPT 3.5 came out, I'm trying to remember this, the price per million tokens for the best model for reasoning at the time was, I think, $60 per 1 million tokens. Some ridiculous number like that. And then less than 2 years later, Llama 3, 8 billion was like 20 cents, if that, something like that. I mean, I have a chart somewhere that I can look at. So the inference prices have fallen dramatically. One view is that the model providers, the frontier model providers, may just buy their way into the market. In other words, you make the models so cheap that the business case becomes irrelevant. Then it becomes more about governance. Can you monitor those? Can I safely deploy them in a cloud of my choice? So I think other factors will come into play around that. But that market around SLM versus LLM, I think that the business model will have a significant role to play in that. I think the second lever that these frontier model providers are going to do is what OpenAI did, which is release their version of open source model, which is so far capable than anything else that the open industry had at that point, with GPT-3, OSS, 20 billion and 120 billion parameter model that they did. I think we'll definitely see that. For regulated industries, so this is where the role of regulation and legislation becomes really important. For regulated industries, however, where you have cost, regulation, geopolitical boundaries, being able to monitor and validate the steps that I've taken, I think the small models will still have a role to play. But I think what's going to be interesting is, with 2.5 million approximately models on Hugging Face, do you really care who your open model provider is, so long as you can deploy that model and have all of those 5 factors come true? In other words, on the open leaderboard of models, the top 25 spots, I think there is only one US model. That's the GPT OSS 120 billion parameter model. The rest there is one French model, like step 3 or 4. The rest are all Chinese models.
Well, that's why I asked you about the Chinese earlier. We're saying we're way ahead. You confirm that we're ahead, but it doesn't always feel like it.
The gap isn't too far, right? They are absolutely catching up. Right.
What was your take? We've been talking a lot about nation states, which leads me right into sovereign AI. What's your take on sovereign AI?
I think it's going to be imperative. It absolutely is for any country, any nation state to survive. I think you'll begin to see. Listen, the big powers. I don't want to call them hegemonic powers, but the big powers with deep enough pockets, they are going to continue to assert their dominance and build on their dominance. That's the U.S. and the China. The intermediate powers, if I can call them that, if not the lesser powers, the intermediate powers, they will have to forge new alliances, and they will have to spend an outsized amount of money building their own digital sovereignty, because they are going to be at the risk of being consumed and dictated to by the hegemonic powers in AI as well. So that's why we see the significant investments that we see from all of the nation states, right? That approximately $1 trillion that I talked about, that's the money that's being invested by countries around the world.
So, the way you explain this, and see, since I'm the host, I can be agnostic. That's the best thing about the host.
Yeah.
But the way you explain it, you're leading to a scenario where, continue with nation states, there's the have and the have-nots, meaning there's going to be more power into fewer nation states that achieve or get closer to AGI the fastest. And I presume that would lend me to believe that would also translate into all of humanity, I guess, being cast into those that have and are taking advantage of AI versus those that don't. There's going to be a distinction, or it has a tendency in the way you explain it, to have a tiered class system based on AI unless the social impacts are addressed.
Absolutely. I mean, listen, we'll run out of time. I think AGI and its implications requires a separate conversation altogether. Not that I'm trying to reinvite myself to the podcast, but
no, that's perfect. That's perfect. We do need to talk about AGI. I mean, maybe that's probably the first 30 minutes alone to get through some of that.
Yeah, and then how do we define AGI? What is AGI, right? What does it truly mean? Because even the industry continues to redefine AGI in a much narrower definition than what perhaps general public understands it to be. Well, listen, thank you for having me. I hope it was, whatever I shared was, if nothing else, hopefully it gave you some food for thought.
It's food for thought. It's more than food for thought. I think it's, look, I know you're doing a lot of research. I'm reading a ton, listening to the experts. Like I say, the irony here is the more you listen to the experts, they seem more fearful than the non-experts. I guess usually it's the other way around, right? It's usually the experts that are saying, calm down, relax. But it's actually the experts in this case that are putting up the red flags, I feel like.
Yeah. I'm just going to say this, that when GPT 3.5 was released, the researchers and employees at OpenAI, they were already playing with GPT-4. Now, think back to the time when us as consumers experienced GPT 3.5 the first time, and then the uplift we got from 3.5 to 4.0. So when experts, and I say that in air quotes, when they are afraid, that's because they probably have access to better and fast other tools that the rest of the world knows about.
A great way to leave the audience. Fantastic. All right, look, we'll have you back. I've got some of the other questions I want to get through. We'll get through AGI next time. I want to talk about things like, hey, does data governance really matter? I mean, we talk about data, you're only as good as data, but can AI separate, or will it be able to separate fact from fiction as we move forward? I want to talk about some of the AI battlegrounds. I want to talk about the power quandary we're in. And I don't know, agents, there's so many other things. Thank you, Manav. I always like talking to you. We have these discussions, like I say, I got the privilege of having these discussions in the hallway so that others don't have. So I'm trying to bring the hallway to the podcast. So thank you for that.
Thank you for having me.
All right. Hey, folks, thank you for listening. Hit us on almartintalksdata@gmail.com. We'll get back to you. We'll get the people you want on. Thank you for listening. Rate us where you can. We'll talk to you next time. Bye-bye.